Hello everyone, welcome back to my channel. In this video I just wanted to show you my custom priority hold circuit for my 182 key system. This is actually custom made from an Arduino, and I actually built the flutter generator as well. If you're familiar with 182 key phones, the normal hold flutter looks like this, and then when compared to priority hold flutter, it blinks at about 12 times per second, which is much faster than the regular hold flutter. This would be used if you had a large number of key lines, or if you had just a few lines and you knew that, for instance, this was used in a hospital or something and a doctor was on this line. You wanted to make sure that that call got answered first before just someone asking about a question. So this utilizes two different hold buttons. Normally you would have a different key strip that has two hold keys. So the secondary priority hold key would be located here, but nobody's ever seen one of these key strips as far as I know. So I'm just using two of the same exact key strip, and this one here is equipped for priority hold. The hold key, if you open up one of these phones, actually has a couple sets of contacts, but the main contact in it is normally just used to open the circuit and disconnect the A lead. But what the priority hold key does is it actually moves the A lead for that line over to a different wire to temporarily connect it to the supplementary hold detector. So that way it'll press down and connect the supplementary hold detector and put the line on hold with the priority hold flash. Otherwise it's just a regular hold flash. And if we look under here at what I've built, just so you can see, this is my circuit right here, and I've posted a few other videos already talking about how this works, and I'm just going to discuss that again in this video. If you want to watch more of my process of actually building this thing, feel free to check out my other videos. Basically I have an Arduino Nano with a code that I wrote, and I'll try and post a link to my code. And if I was too lazy to do that, go ahead and leave a comment if you're trying to build this circuit, and I'm happy to help you, and I'll link the code for free. Just I'm not really sure if anybody's going to be trying to build this, but basically I have an H bridge up here with the first two outputs connected straight to pin 6 of my Arduino. This is my flutter generator, and this is normally used to drive some sort of motor anywhere from, I think it's like 6 or whatever number low voltage, and then up to, I think, 30 volts DC. But for my purpose, the lamps on a key phone are about 9 volts, and I have my lamps on a 9 volt DC power supply. And so my 9 volts DC goes into this screw terminal, which is labeled positive 12 volt, and then there's ground. For my key system, lamp ground is actually negative power now, because of actually the 400E cards that I use. These little light bulbs that are in them will only turn on in that configuration with negative ground. But also for the Arduino, it operates better with a negative ground, just if you're using the commands I did in my program of input pull up, because then you can have negative ground here on the AI lead or A1 lead, and then when a key line is accessed, the Arduino is constantly reading these 4 lines that I have it connected to, and these are connected to the analog 1, 2, 3, and 4 pins of my Arduino. And I'm going to be posting a video showing my troubleshooting process. I basically sat with a laptop connected to the serial monitor so that I could see what the analog output was on the Arduino. And basically there's a 300K resistor in between the analog pin and the wire, but otherwise it's straight through. The only reason why I had to put a resistor there is because the Arduino would otherwise keep these 4 lines linked, where whenever you access any of them, it bridges ground to them, so that was bad. So 300K resistors on each one of the pins, and then the analog inputs can read a certain variable from 0 to about 1020, I think. And when the line is dead, it reads at about 300, and then if you put it on hold, it's about 390, and then if you put it on priority hold, it'll detect a positive boost, because the I-hold lead of the key phone is connected to positive 5 volts through a 680 ohm resistor. So it will detect about, it was around 700-ish on the analog input if priority hold key was pressed. And then if you're accessing the line, it's at about 900. So using those numbers, I could go ahead and build a program to tell the Arduino that, okay, if this line is reading dead, go ahead and remove priority hold if it was on priority hold. By default, the priority levels are all set to 0, and it's only looking for a priority hold condition. So by default, it doesn't really care if the line is dead or if it's accessed or if it's on hold. But if we're looking for a priority hold signature to put the line on priority hold, then it will place a priority hold condition for whatever line that was needed for priority hold, and the Arduino will then set an integer inside and say, okay, line 1 is on priority. And then once it's in priority mode, it'll check every so often to see if the condition has changed. So A, if the line has gone dead or dropped, so if the customer hung up, or if the line was reaccessed. If either of those two happen, it will remove priority condition and switch the lamp back to normal operation. And so this was kind of tricky to get that all to work, and took me a while to write the code to actually work correctly, because my priority conditions kept false triggering, and sometimes if I put the line just on regular hold, it would go into priority, and it was just a big mess to figure it out. And I'm thinking in the future I'm probably going to continue adding to this, because I'm planning on putting in a power saver, because I'm using this big transformer here to give me motor AC power as well as buzzers, and also to power a 4A speakerphone that's located at this desk right up here. And it just doesn't need to be running constantly, and it gets kind of warm. So I'm thinking about making a relay operated outlet down here, so that if there's light in the room, if any lights are turned on, if it's bright in here, it'll turn on the relay for a certain amount of time, and eventually if the lights go off or what have you, it'll switch off the relay so this transformer isn't constantly running. This will also be helpful because sometimes I accidentally leave my 4A speakerphone on and leave the room, because the little stupid light that's on the 4A is just too dim that I don't really notice it. But anyway, this how my relay tree here works. I have 4 relays connected to the Arduino. All of them have ground, So there's a wire that's connected to one pin of the actual relay coil that's just going straight to ground of the Arduino, and then the positive lead of each of these, it's not really polarity sensitive, but that's going to a pin here on the Arduino, so each one of these can be addressed individually. And then there's a clamping diode, which is very important so that you don't fry your Arduino, because otherwise it will wear out and sometimes instantly kill the Arduino because it gets a reverse voltage spike. I haven't personally ever killed an Arduino, I just know from experience using relays that they do that. And what each relay does is the common goes straight to my lamp of each line. So the lamp wire, which is positive 9 volts. And then the normally closed is connected to this screw terminal block. The reason why I had it as a screw terminal block is because these wires actually go up to the key system, and I don't want to deal with soldering those directly on here in case I need to remove this. But these are the regular lamp leads. So these come off the line cards in the key system. So by default, if the priority hold condition is 0, where the priority hold is not active, it'll just keep those wires connected to the lamps, and the lamps on the lines will operate as normal, almost like this never was even on the circuit. But if priority hold is detected, it switches the relay on for that particular line and then bridges the lamp common lead over to normally open, and then they're all commoned to the H bridge, and I'm using 2 outputs of the H bridge to make sure I have enough amps. This thing is barely heated up even when I have it running for a bit. And so I'm thinking even if I add more key phones, it really shouldn't be an issue, because this thing is meant to be able to supply up to 2 amps at peak and then 1 amp, I think, continuously. But since it's just fluttering constantly, it's really not supplying a constant hard power. And so far, that whole part of the circuit, I didn't have any issues with it. And I put a bit of code in the Arduino so that if the priority hold conditions are all 0, where all the lines are not needing priority, it'll shut off the H bridge. So right now the H bridge is just at 0, so then the Arduino and the H bridge aren't just uselessly using power to keep that flutter going. All that is, though, is the Arduino raising and lowering one pin up and down 12 times per second. So, and the reason why I got that number is both from observing SXS Phil's video, where he actually showed a working priority hold system, but also from documentation from Bell System. It specified that it should operate with about 12 interruptions per second. And after building this, it looks pretty much identical to Phil's video, so you can't even tell this thing is fake. But it's very neat because now I actually have priority holds without needing the original cards. Because the original cards, I would have hooked them up and used them if I could get my hands on any. But so far nobody seems to actually really have any of those available because they're extremely rare key system cards. But hopefully in the future more people will want to build this if they have the know-how. And I'm happy to walk people through what I did in order to get it to work. And maybe in the future I'll feel like building some more for people. But right now I'm just happy that it works. I was having issues in some of my previous videos I was trying to film where it wouldn't actually go on priority hold because this key strip was pulled out of a dead gunky call director and it would basically interfere with putting the line on hold, because the contacts to switch between the positive 5 volt for priority hold sense and the regular A lead contact were too close, so it could barely go on priority hold before it switched back. And so I was able to bend those apart again and clean them off, and now it's operating as it should. So now it's pretty low fail rate, where I can press it pretty quickly and it goes on priority hold. And you can go on regular hold. And it's neat because you can actually see this condition on all of the key phones. So you can actually see the priority hold flutter. With the Autovon, I think is very neat because the Autovon system just in general had a lot more specialty equipment. So I'm thinking about rewiring the exclusion key to connect or disconnect the priority hold wire in the hold key, so then I can raise this and press the hold button to put a line in priority or not. And I'm also thinking about adding another feature into my system, since by default my Arduino is always listening to these 4 lines. I could say that if I access the line, put it on hold, this one, this one, this one, if all 4 are on hold, that it would keep track of which ones were accessed first and put on hold first, to put the first one that I put on hold in priority mode. So then it would actually keep track that this one was needing to be re-answered first. But that would be a lot more work and hassle to do that. So we'll see down the line which things I want to potentially add to the system. Anyway, thank you for watching. If you have any other ideas for trying to recreate rare phone equipment, let me know, and I might have some ideas on how to do it. And I'm happy to help with anybody's project if they have sort of a labor of love trying to recreate something that's long been extinct, as far as trying to actually make equipment again. So anyway, thank you for watching, and be sure to check out the other videos on my channel.